Space warfare is combat that takes place in outer space, i.e., outside the atmosphere. Space warfare therefore includes ground-to-space warfare, such as attacking satellites from the Earth, as well as space-to-space warfare, such as satellites attacking satellites. It does not include the use of satellites for espionage, surveillance, or military communications. It does not technically include space-to-ground warfare, where orbital objects attack ground, sea or air targets directly. But the public and media frequently use the term to include any conflict which includes space as a theater of operations, regardless of the intended target. For example, one might describe a rapid delivery system in which troops are deployed from orbit as space warfare, even though the U.S. military uses the term as described above. In the early 1960s, the U.S. military produced a film called Space and National Security which depicted space warfare. From 1985 to 2002 there was a United States Space Command, which in 2002 merged with the United States Strategic Command. There was a Russian Space Force, established on August 10, 1992, which became an independent section of the Russian military on June 1, 2001, and was ultimately replaced by the Russian Aerospace Defense Forces starting December 1, 2011. Only a few incidents of space warfare have occurred in world history, and all involved training missions, as opposed to actions against real opposing forces. In the mid-1980s, a USAF pilot in an F-15 successfully shot down the P-78-1, a communications satellite in a 345-mile orbit. In 2007, China used a missile system to destroy one of its obsolete satellites. And in 2008, the United States similarly destroyed its malfunctioning satellite USA-193. As of 2015 update, there have been no human casualties resulting from conflict in space. History. Early efforts to conduct space warfare were directed at space-to-space warfare, as ground-to-space systems were considered to be too slow and too isolated by Earth's atmosphere and gravity to be effective. The history of active space warfare development goes back to the 1960s when the Soviet Union began the ELMAS project, a project designed to give them the ability to do on-orbit inspections of satellites and destroy them if needed. Similar planning in the United States took the form of the Blue Gemini project, which consisted of modified Gemini capsules that would be able to deploy weapons and perform surveillance. One early test of electronic space warfare, the so-called Starfish prime test, took place in 1962, when the United States exploded a ground-launched nuclear weapon in space to test the effects of an electromagnetic pulse. The result was a deactivation of many then-orbiting satellites, both American and Soviet. The deleterious and unfocused effects of the EMP test led to the banning of nuclear weapons in space in the Outer Space Treaty of 1967. 1970s, 1980s through the 1970s, the Soviet Union continued their project and test-fired a cannon to test space station defense. This was considered too dangerous to do with the crew on board, however, so the test was conducted after the crew had returned to Earth. Space warfare strongly influenced the final design of the United States Space Shuttle. The distinctive delta wing shape was needed if the shuttle were to launch a military payload towards the Soviet Union and perform an immediate orbit after one rotation to avoid being shot down. Both the Soviets and the United States developed anti-satellite weaponry designed to shoot down satellites, while early efforts paralleled other space-to-space warfare concepts. The United States was able in the 1980s to develop ground-to-space laser anti-satellite weapons. None of these systems are known to be active today, however. A less powerful civilian version of the ground-to-space laser system is commonly used in the astronomical technique of adaptive optics. 2000s, the People's Republic of China successfully tested a ballistic missile-launched anti-satellite weapon on January 11, 2007. This resulted in harsh criticism from the United States of America, Britain, and Japan. See 2007 Chinese anti-satellite missile test. The U.S. developed an interceptor missile, the EDM-3, testing it by hitting ballistic test targets while they were in space. On February 21, 2008, the U.S. used a EDM-3 missile to destroy a spy satellite, USA-193, while it was 247 kilometers above the Pacific Ocean. Japan fields the U.S.-made EDM-3 missile, and there have been plans to base the land-based version in Romania and Vietnam. Theoretical space weaponry. Ballistic warfare. In the late 1970s and through the 1980s, the Soviet Union and the United States theorized, designed and in some cases tested a variety of weaponry designed for warfare in outer space. Space warfare was seen primarily as an extension of nuclear warfare, and so many theoretical systems were based around the destruction or defense of ground and sea-based missiles. Space-based missiles were not attempted due to the Outer Space Treaty, which banned the use, testing or storage of nuclear weapons outside the Earth's atmosphere. Systems proposed ranged from measures as simple as ground and space-based anti-missiles to railguns, space-based lasers, orbital mines, and similar weaponry. Deployment of these systems was seriously considered in the mid-1980s under the banner of the Strategic Defense Initiative. If the Cold War had continued, many of these systems could potentially have seen deployment. The United States developed working railguns, and a laser that could destroy missiles at range, though the power requirements, range, and firing cycles of both were impractical. Electronic warfare. With the end of the Cold War and continued development of satellite and electronics technology, attention was focused on space as a supporting theater for conventional warfare. Currently, military operations in space primarily concern either the vast tactical advantages of satellite-based surveillance, communications, and positioning systems or mechanisms used to deprive an opponent of said tactical advantages. Accordingly, most spaceborne proposals which would traditionally be considered weapons are designed to jam, sabotage, and outright destroy enemy satellites, and conversely to protect friendly satellites against such attacks. To this end, the U.S. is researching groups of small, highly mobile satellites called microsats and picosats in volume, nimble enough to maneuver around and interact with other orbiting objects to repair, sabotage, hijack, or simply collide with them. Kinetic bombardment. Another theorized use involves the extension of conventional weaponry into orbit for deployment against ground targets. Though international treaties ban the deployment of nuclear missiles outside the atmosphere, other categories of weapons are largely unregulated. Traditional ground-based weapons are generally not useful in orbital environments, and few if any would survive re-entry even if they were. But as early as the 1950s, the United States has toyed with kinetic bombardment, i.e., orbiting magazines of non-explosive projectiles to be dropped onto hardened targets from low Earth orbit. Kinetic weapons have always been widespread in conventional warfare: bullets, arrows, swords, clubs, etc. But the energy a projectile would gain while falling from orbit would make such a weapon rival all but the most powerful explosives. A direct hit would presumably destroy all but the most hardened targets without the need for nuclear weapons. Such a system would involve a spotter satellite, which would identify targets from orbit with high-power sensors, and a nearby magazine satellite to deorbit a long, needle-like tungsten dart onto it with a small rocket motor, or just dropping a very big rock from orbit. This would be more useful against a larger but less hardened target. Though a common device in science fiction, there is no publicly available evidence that any such systems have actually been deployed by any nation. Directed energy weapons. Weapon systems that fall under this category include lasers, linear particle accelerators or particle beam-based weaponry, Microwaves and plasma-based weaponry. Particle beams involve the acceleration of charged or neutral particles in a stream towards a target at extremely high velocities, the impact of which creates a reaction causing immense damage. Most of these weapons are theoretical or impractical to implement currently, aside from lasers which are starting to be used in terrestrial warfare. That said, directed energy weapons are more practical and more effective in a vacuum than in the Earth's atmosphere, as in the atmosphere the particles of air interfere with and disperse the directed energy. Practical considerations. Space warfare is likely to be conducted at far greater distances and speeds than terrestrial combat. The vast distances involved pose difficult challenges for targeting and tracking, as even light requires a few seconds to traverse ranges measured in hundreds of thousands of kilometers. For example, if attempting to fire upon a target at the distance of the Moon from the Earth, the image one sees reflects the position of the target slightly more than a second earlier. A projectile from a railgun recently tested by the U.S. Navy would take over 18 hours to cross that distance. Even a laser will need approximately 1.28 seconds, meaning a laser-based weapon system would need to lead a target's apparent position by 1.28 times 2 equals 2.56 seconds. Three factors conspire to make engaging targets in space very difficult. First, the vast distances involved mean that an error of even a fraction of a degree in the firing solution could result in a miss by thousands of kilometers. Second, space travel involves tremendous speeds by terrestrial standards. A geostationary satellite moves at a speed of 3.07 kilometers per second, whereas objects in low Earth orbit can move at up to 8 kilometers per second. Third, though distances are large, targets remain relatively small. The International Space Station, currently the largest artificial object in Earth orbit, measures slightly over 100 meters at its largest span. Other satellites can be orders of magnitude smaller, e.g., Quickbird measures a mere 3.04 meters. External ballistics for stationary terrestrial targets is enormously complicated. Some of the earliest analog computers were used to calculate firing solutions for naval artillery, as the problems were already beyond manual solutions in any reasonable time, and the issues in targeting objects in space make a difficult problem even harder. Additionally, though not a problem for orbital kinetic weapons, any directed energy weapon would require large amounts of electricity. So far the most practical batteries are lithium batteries, and the most practical method of generating electricity in space is through photovoltaic modules, which are currently only up to 30% efficient, and fuel cells, which have limited fuel. Current technology might not be practical for powering effective lasers, particle beams, and rail guns in space. Regardless of one's reasons for going to war, at present those reasons are not likely to suggest major targets located in space. Most of the main theories which attempt to explain human proclivity for warfare, psychological, sociological, demographic, economic, political, or otherwise, would not indicate space as a likely location of conflict until a significant population is engaged in large-scale activity there. Until then, space warfare is likely to take a supporting role to conventional, terrestrial warfare, aside from applications such as communications, reconnaissance, GPS, and the like, which would be difficult or impossible without satellites. There do not appear to be any major advantages to basing weapons systems in space. The main reason is simply cost. Space warfare that involves humans being deployed in space to fight each other is not currently practical because of the difficulty and cost of sustaining human life in space, especially over long periods of time. Additionally, there are few things that could be accomplished by space warfare that any nation wealthy enough to finance them cannot accomplish far more cheaply through conventional means. Raising any significant mass beyond Earth's gravity will always require a large amount of energy, and the cost increases with mass. For example, though kinetic bombardment potentially offers the ability to strike any target anywhere in the world within minutes, both the United States and Russia, possibly the only nations with the resources and facilities necessary to implement such a system, have sufficiently long-range supersonic bombers that the same target could already be destroyed in a matter of hours at a mere fraction of the cost. Anti-satellite attacks, especially ones involving kinetic kill vehicles, can contribute to the formation of space debris which can remain in orbit for many years and can interfere with future space activity or, in a worst case, trigger a Kessler syndrome. The PRC is reported to be developing soft kill techniques such as jamming and vision kills that do not generate much debris. General William L. Shelton has said that in order to protect against attacks, space situational awareness is much more important than additional hardening or armoring of satellites. The Air Force Space Command has indicated that their defensive focus will be on disaggregated space architectures, possible warfare over space. Most of the world's communications systems rely heavily on the presence of satellites in orbit around Earth. Protecting these assets might seriously motivate nations dependent upon them to consider deploying more space-based weaponry, especially in conflicts involving advanced countries with access to space. Even without the further militarization of space, a future conflict conducted largely on the ground through conventional means might well be sparked by actions conducted entirely in space. Alternatively, the very threat of space warfare may be enough to put considerable pressure on the political system of a nation, such as the pressure which caused the formation of the Outer Space Treaty. Space warfare in fiction. Space warfare is a topic often touched upon in science fiction, with a wide range of realism and plausibility, from stories based on anticipated future technology and tactics, to fantasy or historically based scenarios that happen to take place in a science fiction background. Some portray a spaceborne military will be similar to an air force, whereas others depict a more naval analog. Still others suggest forces more like Marines, highly mobile forces engaged in interplanetary and interstellar warfare, but with most of the actual conflict occurring in terrestrial environments. Both kinetic energy and directed energy weapons are often portrayed, along with various military space vessels. The Lensman series by E. Smith is an early example, which also inspired the term space opera due to the grandiose scales of the stories. The Ender's Game series by Orson Scott Card is a notable example in that it makes conjecture as to what sort of tactics and training would be required for war in outer space. Other science fiction authors have also delved into the tactics of space combat, such as David Weber in his Omniverse series, as well as Larry Niven and Jerry Pournelle in their Mote in God's Eye series. A more recent example would be Alistair Reynolds' Revelation Space Universe, which explores combat at relativistic speeds. Robert A. Heinlein's Starship Troopers is perhaps one of the best-known and earliest explorations of the space marine idea. Space-based vehicular combat is portrayed in many movies and video games, most notably Star Wars, the Halo series, Descent, Gundam, Macross, Babylon 5, and Star Trek. Games such as the Homeworld series provide interesting concepts for space warfare, such as game mechanics using three-dimensional battle formations, the use of plasma-based projectors that receive their energy from a ship's propulsion system, and automated unmanned space combat vehicles. Other series, such as Gundam, prominently feature vehicular combat in and among many near-future concepts, such as O'Neill cylinders. The distinct fictional settings in which space warfare occurs are far too numerous to list, but popular examples include Star Trek, Stargate, Warhammer 40,000, Star Wars, Babylon 5, Buck Rogers, Flash Gordon, Battlestar Galactica, Mass Effect, Free Space. the Halo series and many comic book franchises. Video games have frequently touched the subject, with the Wing Commander franchise serving as a prototypical example. Note that very few games attempt to simulate an environment with realistic distances and speeds, though Independence War and Frontier Elite 2 both do, as does the board game Attack Vector. Tactical